Have you ever gazed up at the night sky filled with countless stars and wondered how we could possibly reach those distant worlds? Ever wondered how we reach the stars and the moon? The answer: the incredible machines that defy gravity and propel us into the vast unknown. Rockets. A rocket is a powerful vehicle, an engineering marvel designed to overcome the immense forces that hold us to Earth. Rockets are designed to travel far beyond where airplanes can go, soaring to altitudes that no conventional aircraft could ever reach. They are built to venture into the ultimate frontier, into space itself. Unlike cars or planes which rely on the environment around them, rockets carry all their own fuel and oxidizer, the essential ingredients for combustion, so they work even in the vacuum of space where there's no air to breathe or fuel a fire. Their main job? What is the fundamental purpose of these incredible machines? To generate enough power, enough thrust, to break free from Earth's gravity, that invisible force that constantly pulls us down, and to deliver people, precious cargo, or vital equipment into the vast expanse of space. Rockets come in all sizes, from small-sounding rockets to colossal launch vehicles, but their purpose is the same: to explore the universe beyond our planet, to push the boundaries of human knowledge and understanding. When you see a rocket standing tall on the launch pad, see more than a machine, more than just metal and wires. See a symbol of human curiosity, our relentless pursuit of knowledge, and our innate drive to explore the unknown. Rockets are our ticket to the stars, our pathway to new discoveries and a deeper understanding of our place in the cosmos. They are built by teams of dedicated scientists and engineers, brilliant minds who dare to dream big and push the limits of what's possible. Every launch is a step toward discovery, a bold leap into the future, a promise to keep reaching for the cosmos, to never stop exploring, and to continue unraveling the mysteries of the universe. Why do we need rockets, these incredible machines? Because they're the only reliable way to send vital things into space. Satellites that power your GPS and navigation systems, TV and weather forecasts, all depend on rockets. All get there by rocket. Rockets also launch robotic explorers to other planets, capturing stunning images of Mars, Jupiter, and beyond. They carry astronauts to the International Space Station, where we learn how space affects the human body. Rockets make continuous human presence in space possible and inspire us to dream bigger. Every launch pushes the boundaries of science and technology. Rockets are more than just machines, they're our bridge to the universe. Ever wondered how these colossal metal structures defy gravity and soar into the vast expanse of space? How does a rocket lift off? The secret lies in a fundamental principle of physics. It's all about Newton's third law, a cornerstone of understanding motion, stating that for every action, there's an equal and opposite reaction. This law governs how forces interact and is crucial for understanding rocket propulsion. To grasp this concept, imagine throwing a ball while standing on a skateboard. As you exert force to throw the ball forward, you roll backward as the ball moves forward. This simple demonstration perfectly illustrates Newton's third law in action. Rockets do the same, but instead of a ball, they push super-hot gases downward at high speed. These gases are the product of intense combustion within the rocket engine. This downward blast creates thrust, the force that lifts the rocket up, counteracting the relentless pull of gravity. If thrust beats gravity, if the force pushing the rocket upward is greater than the force pulling it down, the rocket soars skyward. Think of a balloon. Let go, and air rushes out one end, propelled by the pressure inside, sending the balloon flying the other way. The escaping air is the action, and the balloon's movement is the reaction. Rockets use controlled explosions for a much bigger sustained push. This continuous thrust is what allows rockets to reach incredible speeds and escape Earth's gravity. So, when you see fire and smoke at launch, remember, the rocket is pushing down hard to break free from Earth. It's a monumental effort requiring immense power and precise engineering. It's physics in action, turning fuel into a powerful journey to space. A journey fueled by the fundamental laws that govern our universe. That's the magic behind every launch. A testament to human ingenuity and our understanding of the world around us. A rocket is a team of parts working together. At the top is the payload. Satellites, telescopes, or astronauts, protected by a nose cone. Below that, the guidance system acts as the rocket's brain, steering it on course. Most of the rocket is taken up by giant fuel and oxidizer tanks. These provide the energy for liftoff. The fuel and oxidizer, called propellants, burn together to create the rocket's fiery thrust. At the bottom, powerful engines mix and ignite the propellants, blasting hot gases out at high speed. The nozzle shapes and accelerates these gases, generating the thrust needed to escape gravity. Each part has a crucial job, and together, they make space travel possible. That's the anatomy of a rocket. A rocket launch is a carefully planned sequence. Hours before launch, the rocket is filled with super cold propellants and checked by engineers. The countdown begins. 10, 9, 8, as systems activate and engines ignite. At liftoff, clamps release and the rocket rises, slowly at first, then faster, roaring into the sky. The rocket faces its toughest challenge at max Q, when air pressure is highest. As it climbs, empty fuel tanks drop away, making the rocket lighter and faster. Multi-stage rockets ignite new engines as old stages fall off. Finally, the payload is released into orbit. Mission accomplished. The rocket's job is done. It's delivered its cargo to space. Every launch is a blend of science, engineering, and teamwork. That's how we reach the stars. Throughout the history of space exploration, certain rockets have transcended their engineering and become legends, symbols of human ingenuity and our boundless ambition to explore the cosmos. These aren't just machines. They represent pivotal moments in our journey beyond Earth. First among these titans is the Saturn V, the colossal workhorse that propelled the Apollo missions and took astronauts to the moon, fulfilling a dream that once seemed impossible. It was the rocket that defined an era. Standing taller than a 36-story building, it was a true behemoth of engineering, a testament to what humanity can achieve when united by a common goal. The Saturn V generated immense power, enough to escape Earth's gravity and send humans on an unprecedented voyage to another world. Then came the Space Shuttle, a marvel of engineering that was partly reusable, a winged spacecraft that could return to Earth and fly again. It launched like a rocket with the raw power needed to break free from our planet's embrace. But unlike its predecessors, it landed like a plane, gliding gracefully back to Earth on a runway, ready for its next mission. The Space Shuttle played a crucial role in building the International Space Station, a symbol of international collaboration in space. It was also responsible for deploying the Hubble Space Telescope, which has revolutionized our understanding of the universe. Today, SpaceX's Falcon 9 represents a new era in space travel. It has changed the game with reusability, a key step towards making space travel more accessible and sustainable. Uniquely, its first stage lands itself after launch, a feat of engineering that was once considered science fiction. This reusability is making space access cheaper and more frequent, opening up new possibilities for exploration and commerce. Each of these rockets marks a significant leap in our journey, pushing the boundaries of what's possible and inspiring future generations of engineers and explorers. Saturn V for exploration, a symbol of our first giant leap. The Space Shuttle for living and working in space, expanding our presence beyond Earth. And Falcon 9 for sustainable travel, paving the way for a future where space is more accessible to all. They're not just rockets, they're milestones in our ongoing quest to reach farther, to explore new worlds, and to understand our place in the universe. These superstars inspire the next generation of rockets, the designs and technologies that will shape the future of space travel, ones that may one day take us to Mars and beyond, pushing the boundaries of human exploration even further. Every breakthrough builds on the last, each success paving the way for even greater achievements in the future. The adventure continues, and the next chapter is waiting to be written. Rockets are more than machines, they're symbols of human curiosity and courage. They're our only way to break free from Earth and explore the universe. Every launch is physics in action, turning dreams into reality. Rockets help us answer big questions. Are we alone? How did our solar system form? They expand our knowledge of space and Earth and inspire new generations to dream bigger. The future of space travel is bright with new rockets aiming for Mars and beyond. So next time you look up, remember rockets are our bridge to the stars. The universe is waiting for us to explore.